Hello friends, this video on number systems part 3 is brought to you by examfear.com. No more fear from exam. So we talked about natural number, whole number, integers, rational number, irrational. Let's talk about real numbers. Real numbers are the number which you can plot in number line. And their real number, they exist for real, and that is denoted by R. Okay, so and these real number is nothing but both rational number and irrational number. If you combine these two set of numbers, you get real numbers. Example can be irrational can be root 2, root 3, pi. Rational can be minus 1, 0, 1 by 2, 3 by 2, stuff like that. All these numbers which you can plot on the number line are real number. Okay. Definition of real number: anything which you can plot on the number line is real number. Apart from real number, there is something called imaginary number. Imaginary number, they don't exist. They are imaginary. That is denoted by I, and there is nothing but root of minus 1. So we will not talk about imaginary number in this class. Maybe in the higher class you will understand imaginary number. This is not required as of now. But understand that the whole number system consists of real number and imaginary numbers, right? Something you can write 2 plus 3i, 2 plus i3, let's suppose. This is the imaginary part and this is the real part. For now, not required. Real numbers is the maximum we are going to learn, and real number is nothing but you combine rational numbers and irrational number, what you get is real number. And real number is something which you can plot on the number line. So every point on this number line represents a real number. If you talk about this point, it represents the real number. If you talk about this point, it represents a real number minus 7. If you talk about this point, it represents a real number 0. If you talk about something here, so it must be representing some real number. So in this case, it may be 4.5, that is 9 by 2. And that is a real number. Okay. If you want to plot root 2, so root 2 will be somewhere here. This will be root 2, and that is also a real number. We'll talk about that. We'll see how we plot root 2, root 3 and stuff like that on the number line. But anything that you can plot on number line is real number. So let me quickly brush up all these concepts. Natural number, something which you can count on fingers. 1, 2, 3, 4. Right? Minus 1, minus 2, minus 3, 0, all these are not natural numbers. But 1, 2, 3, 4, 5, 6, this is a natural number because you can count on fingers. Whole number, the only addition is 0 by Aryabhatta, the Indian philosopher. Since it has such a huge importance, we got a new set of numbers altogether, whole number, that is 0 plus natural number. Then we have integers which has negative numbers as well. And then we have rational number which you can write in the form of p by q. Please note, minus 1, minus 2, minus 3 are also rational number because minus 1 I can write as minus 1 by 1. Minus 2 I can write as minus 2 by 1. And these are all, and then we have irrational numbers which you can't write in the form of p by q. For example, root 2, root 3 and pi. All these real rational number and irrational number combine to form real numbers. Okay. We'll take some examples for real number, true and false. Every whole number is a natural number. Is it true or false? So let's take a whole number 0. Is 0 a natural number? Answer is no. That means it is false. Don't take 1. Like, see, 1, take something which is exclusively a whole number. If you say, let's take a whole number 3 and say, is 3 a whole natural number? Answer is yes. But you have to take all the numbers, right? So typically we take the numbers which are special with whole number. That is 0. Okay, please don't get confused here. Don't say that 5 is a whole number and 5 is also a natural number. So you can have a natural number which is a whole number, but not every whole number is a natural number. An exception is 0. Because there is every here. If you say the same question as some whole number is a natural number, answer is true. Right? Because you have 1 or 2 or 3, there is a whole number, that is also a natural number. So you should be very careful about these words. If it is some, the whole statement is true. If it is every, the statement is false. The second is every natural number is a whole number. So natural number, we know 1, 2, 3, 4. This is the set of natural number. Let's see. 1 is a whole number. Yes. 2 is a whole number. Yes. 3, 4. All these numbers are whole number. Yes. That means every natural number is a whole number. If instead of every, if you say some natural number is a whole number, in that case also it will be true. Because if you take 4, that is a natural number. Hope you understand. If you say every, then all the numbers in the natural number should be a whole number. If you say some, even if one natural number is a whole number, then the condition is true. Okay. A good example to explain the difference between every and some is, for example, if I say every student watch exam fear videos. Watch exam fear videos. And I think it is a wrong statement. Not every student watch exam fear videos. That is a false statement. But if I say some students watch exam fear videos, then that is a true statement, because yeah, in fact you are a student and you are watching exam fear videos. So these words actually are very powerful words, so please pay attention to these words. Okay, the next example is every integer is a rational number. So let's see the integer set. Integer set is -1, -2, -3, like that. Also 0, +1, +2. Okay, and if you see, all of these are actually a rational number. And rational number has extra numbers like -2, -1/2, 2/7, 3/2. So anything which is an integer has to be a rational number. So this statement is true. Please pay attention here. But the flip side will not be true. You can see this. This is the flip side. Every rational number is an integer. So rational number example can be +1/2, -1/2, -1, +1, 0. Right? All these are example of rational number. Now if you see, +1/2 is not an integer. -1/2 is not an integer. But these are integers. So this statement is false. But if you change every to some, and if you say some rational numbers are integers, then the answer is true, because -1 is a rational number and it is an integer. Okay. Every rational number is a whole number. So let's take example of rational number. Rational number can be 1/2, -1/2. Whole number is 0, 1, 2, like that. So if you see, 1/2 actually is a rational number, but it is not a whole number. Correct? So this statement is also false. So the question is every integer a whole number? Please note the word every. And if you see the integers are -1, -2, -3, 0, 1, 2, 3, stuff like that. Are these whole numbers? If you see -1, -2, -3, they are not whole numbers. This will be false. Okay. So if you make it some integers is a whole number, then it is true, because these are whole numbers 0, 1, 2 and 3. But for this question, the answer will be false. So if my question is some integers are whole number, then the answer will be yes, true. The next example is every irrational number is a real number, true or false. So let's see the irrational number set. √2, √3, pi, these are irrational number. And if you see, all of these irrational number are real number. Actually, we have seen that real number is nothing but rational number and irrational number combined. So it is a true statement. The next is other way around. Every real number is irrational number. So if you see the real number also includes number like 1, 2, 3, 4, 5, right, 0. All these numbers are not irrational. Correct? These are rational numbers. So this is false. So the question says every point on the number line is √m, where m is a natural number. We have to see this. So let's see this point. What is this point? This point is 0. and 0 will be equal to root 0. But 0 is not natural number. Right? You talk about minus 4. Minus 4 is root of nothing. You can't write minus 4 as root of anything, right? You can write plus 4 as root of 16, but minus 4 you can't write root of any number. That number is not there. So thus I can say that every point on the number line is not root m. Example, minus 4 and 0. Because it's constrained that m has to be a natural number. So this is the false statement. Please pay attention here. The question says that every point on the number line is root m, where m is a natural number, and we have seen that minus 4 is a point which cannot be represented as root m, where m is a natural number. Even 0 can't be represented as root m, where m is a natural number. Is 0 a rational number? See, rational number is something which you can write in the form of p by q. Q is not equal to 0, and p and q are integers. 0 I can write as 0 by 1, where 0 and 1 both are integers, and 1 is not equal to 0. Right? P by q. Thus 0 is a rational number. Okay. Let's take some examples here to find 6 rational numbers between 3 and 4. This is 3, this is 4. So what I told, since 6 rational numbers are required, I'll multiply by 10 by 10. I can multiply by 100 as well, but just to simplify the calculation. This is 30 by 10, this is 40 by 10. So let's find some numbers between 30 by 10 and 40 by 10, 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10, 36 by 10. These are 6 rational numbers between 3 and 4. In fact, as we have discussed, there are infinite number of rational numbers between any 2 rational numbers. Okay. Find 5 rational numbers between 3 by 5 and 4 by 5. So 3 by 5 and 4 by 5. Since I have to find only 5 rational numbers, I will multiply by 10 by 10 both sides. So this becomes 30 by 50 and this is 40 by 50. Let's find rational number between them. 31 by 50, 32 by 50, 33 by 50, 34 by 50, 35 by 50, and the list continues. But we want only 5, so we'll stop at 5. Okay. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.